Okay, there's a lot being asked in this problem, but the first step is to determine the equation of a tangent line to f of x equals e to the negative x at x equals 0. So first thing, again, you see equation of a tangent line, you should always write y minus y1 equals m times x minus x1. And in this case, we already know that our x1 is equal to 0. What's y? Let's plug in and figure out. We get f of 0 equals e to the negative 0, which is just e to the 0, which is 1. So we have y minus 1 equals m times x, because it's x minus 0. So now we need to figure out what m is, our slope, by finding f prime. So we have a chain rule here, because it's e to the negative x. So we have the derivative of e to the blah is e to the blah, multiplied by the derivative of blah, derivative of the exponent, is just negative 1. So we get negative e to the negative x. So then what's our slope? F prime 0 is just going to be negative e to the negative 0, which is going to be negative 1. So our slope is negative 1. We have y minus 1 equals negative 1 times x. So that's the equation of our tangent line. So now the next part of this question is asking for the x and y intercepts. So we have y minus 1 equals negative x, right? Negative 1 times x is just negative x. So the x-intercept is going to happen when x is equal to 0. Sorry, no. The x, it's when y is equal to 0, because on our axis, right? If we're intercepting the x-axis, that means that we haven't moved vertically at all, which means y must be 0. So for the x-intercept, we're going to set y equal to 0. So we get negative 1 equals negative x, and then that's pretty simple. We're just going to have 1 equals x. So our x-intercept happens at x equals 1. Okay, so for our y-intercept, that's going to happen when x equals 0. So we have x equals 0 for the y-intercept, because that means that we haven't moved at all in the x direction. We've only moved up and down the y-axis. So we say y minus 1 equals 0, so then y equals 1. So our x-intercept is at x equals 1, y equals 0, and our y-intercept is at x equals 0, y equals 1. We just set y equal to 0 to determine the x-intercept, and we set x equal to 0 to determine the y-intercept. Last thing it was wanting to do is approximate f of point 2 using my tangent line. So this is the equation of the line tangent to the curve at x equals 0, y equals 1. So what we want to do now is just use that tangent line to approximate what f of point 2 would be. So we have y minus 1 equals negative x is our tangent line. And we are just going to plug in point 2 and see what y is equal to. So y minus 1 equals negative 0.2. So then y equals, we're just going to add that 1 to both sides to undo the minus 1. And so negative 0.2 plus 1 is just 0.8. So that's our approximation. F of 0.2 is approximately 0.8. Because if we go back and we try to plug in 0.2 to this, that's kind of hard to calculate. E to the negative 0.2 is going to be something I'm going to need a calculator for. But if I use the tangent line, which is going to be a decent approximation of the function close to where the tangent line occurs, which is x equals 0, so if I go over to x equals 0.2, I'll get a decent approximation of what that function is by just plugging into the tangent line. And that I can do without a calculator, because I can easily do negative 0.2 plus 1, which is 0.8. So final answer, 0.8.